there's two example 4s, but this one is still a 3-type problem. So if you were to do this type of problem that we're going to talk through first and get it right, you would be proficient. Example 4 on the bottom here, and then example 5 on the back. These are going to be examples of 4-type problems. So we're going to practice 2. Example 4 and 5. All right, can we focus? All right. With this type of problem, this is just to practice a little bit again with a story problem, pulling out some of the information that it gives you. So this particular example shows the mean sustained wind velocity. In this case, mean represents average. So the average sustained wind velocity per second in a certain hurricane is given by that function. P is the air pressure. So remember, with a story problem, I like you to write out what your variables mean so that later on, if we have to plug stuff in, you can easily plug it in. And then V represents the velocity. Good. Because it says wind velocity, or how fast it's going. All right, we're supposed to estimate the air pressure at the center of the hurricane when the average sustained wind velocity is 54.5 meters per second. Is that 54.5 a V value or a P value? That's a V. That's a V. So that's going to plug in for V. You might want to grab a calculator because I think we're going to have to divide something here. And then my P is stuck underneath the radical here, but I also have that 6.3. How do I get rid of that 6.3 in order to solve? Divide. So can someone take 54.5 and divide? 8 point what? 8.65. Cam? We just divided both sides by 6.3. You get 8.65 equals, yeah, 1,013. And then to get rid of the radical, I square both sides. So, Ashley, can you tell me what 8.65 squared is? 74.82. Okay, and then if you could take that 74.82 and subtract 1,013 so we can get P by itself. Okay. Now, is P completely by itself yet? No. Not quite, because it has that negative there. So if we divide by a negative, it's going to give me P equals 938.17. Now, because this is a story problem and our variables actually mean something here, we want to make sure that we put units. In this case, the millibars is going to be the units because we're talking about pressure.
What who? Millibar. What's a millibar?
Unit of measurement for the air pressure. Okay. And then today we're not going to have like specific practice except for in the notes on 4-type problems for this standard. But tomorrow we will touch more on that. You good to go?
Yep. Why is it 2 example 4's question?
Because I can't count when I was typing. I know.
You have to spell and count at the same time. That's hard.
Okay, hopefully you're writing. Ladies and gentlemen.
It means rotate, CJ.
There you go. I know, I'm writing though. You'll need to look at the screen.
What are you writing?
On the board. A solution that appears. Alright, so an extraneous solution we'll talk a little bit more about here in a second. But it's a solution that appears when you square or raise to the 4th power function to solve for x. What smaller word is in the word extraneous?
What? Extra.
The smaller word that's in the word extraneous is extra.
What's extraneous mean?
I'm explaining it. So, extraneous is basically a solution that you end up getting. So like you solve your problem and you get an answer, but sometimes the answer that you get does not work, which is really an answer. If you plug it back in and it doesn't work, that just means that your function that you have is unsolvable, meaning there's no solution really. But sometimes when you square or raise to the 4th, really if you raise to an even power to solve for x, it's an extra solution that doesn't end up working. So it's an extra solution that doesn't actually work when we check. Okay. Now, for example 4, this example 4, and example 5 on the next page. Well, let me flip because I want to make sure I read it. Don't flip yourself though. To get a 4 on this type of problem means you can solve a radical equation that involves a radical on both sides of the equation. They give you a short example there. I can write a radical equation that would have an extraneous solution. So we're going to practice this a little bit more tomorrow, but the actual solving those types of problems is what we're going to do right now. So I want you to go ahead and write out 3x minus 2 equals the square root of x plus 5, CJ. Again. I just want you to pay attention. Okay. Usually the other problems that we've done, like the one that we just got done doing, we had one radical that we could easily isolate just by moving numbers around. In this case, though, we have one on either side, so there's not really a way to get one of them by itself. So, we have to do something a little bit different. Normally, to get rid of a radical, in this case the square root, what do we do to both sides? Square. Okay, so let's at least start with something that we know, which we're going to square both sides. On the left side, it's going to get rid of the square root, giving me 3x minus 2. Now here, I can't just get rid of the radical because this power does not distribute over addition. So what we actually have to do on the right side there is we have a binomial, and we are multiplying it by itself, which means if we were to multiply it by itself, what do we end up having to do? If it looks like this, because technically that's what's going on, is we're multiplying it by itself. So we have to, what did you say, CJ? I think you said. We have to FOIL.
How do you FOIL a radical?
We will.
With a lot of love.
Okay, when you multiply radicals together, I'm going to kind of show you off on the side here. How many radicals do I have there? 2. So couldn't I write it like this? Yeah, so, and then that just makes it not a radical, just giving me x. So when you multiply square root of x by square root of x, you get x. Now stick with me here, because this next part, I'm not going to actually write out all the way. Jake and Derek. I know, but you're also talking. Alright, outer terms, 5 times times square root of x gives me 5 square root of x. What do my inner terms give me? 5 times square root of x still gives me 5 square root of x. And then last term's 5 times 5. 25. Well, we have a problem here because don't I still have radicals floating around? Okay, so I still need to get rid of that radical. This is like a two-step thing. So you get rid of the first radical, like here, and then you get to this point, you still have radicals. So now I can isolate those radicals. I'm gonna get those by themselves. Well, first of all, let's go ahead and add them together since they're like terms. 10 square root of x. And then I'm going to isolate that square root of x just like I've done in other problems. I'm going to get that one by itself. So I'm going to subtract 25 from both sides and subtract x. So you get 2x minus 27, right?
Yeah.
I subtracted x from both sides to get the 2x. And then I subtracted 25 from both sides to get the negative 27. Then we're going to divide everything by 10. Now, for these problems, if you're going to end up getting fractions, I'm going to let you go decimal on this just because it's going to be easier for the next thing we have to do. So go ahead and 2 divided by 10 I think is 0.2. What's negative 27 divided by 10? Should be negative 2.7.
Yeah.
And then square root of x. Now I have to square again, right? When I square both sides, squares disappear, giving me x. And then in this case, and this is why this is a 4-type problem, technically that's multiplied by itself, isn't it?
Yeah.
Because it's squared. So we have to FOIL again. Now, there's steps to this, but that's where the difficulty part comes in because you guys know how to solve or get square root of x's by themselves. That's what we did last week and what we're going to continue to do this week. And then once we get to this, you guys have dealt with these types of functions before. Okay? And we've been practicing the things and the tools that you need to solve this. But I'm going to need some help here with the decimals. 0.2 times 0.2 is 0.04. So we'd have 0.04x squared. The outer and the outer terms there, 0.2 times 2.7 is 0.54, and it would be a negative 0.54, right? And then we'd have another negative 0.54. So really, whoops, I'd have, if I added them together, negative 1.08. So that's my outer, my inners added together. And then 2.7 squared. 7.29. Well, because you multiply by some. Yeah, 7.29 equals x. Now, what kind of function do I have there? I know there's decimals, but what's that function called? It's a quadratic. So once you get to a quadratic, you can either solve it by factoring or by quadratic formula. I highly recommend the quadratic formula in this case because you have decimals. So we're going to subtract x because we got to get it equal to 0 if we're going to use the quadratic formula. If I subtract x, I get negative 2.08x, 7.29. And then we're going to, oops, I'm off the screen here. And we're going to use the quadratic formula here. plug information in. Okay, so negative b would be 2.08. Because I had to subtract x. So this is 1x. And if I take away another 1x here, I get negative 2.08. Because I have to get it equal to 0 to solve the quadratic formula. To subtract x. Minus 4 times a times c. The 2.08? Okay, technically this is 1x, right? Okay, so if I have negative 1.08 and I subtract another 1, negative 1.08 minus 1 gives me negative 2.08. Okay? Sean, head up, please. Alright, and then at this point it's just punching out on a calculator. Huh? Well, you punched out already? Got it. There should be 2 answers. I got 48.22 as one answer. I'll kind of show you what I'm doing here. 2.08 minus the radical of 2.08 squared minus 4 times 0.04 times 7.29 divided by 2 times 0.04. Oh. So 3.779. About. Me? That's my work. So you can kind of look there.